Okay, so this is the part C of chapter 25 on the digestive system. So last time we did the route that bile takes. Here we're going to start looking at the components of bile. Bile is composed of minerals, cholesterol, bile acids, which we also call bile salts, bile pigments called bilirubin and biliverdin, and phospholipids. The active ingredient is the bile acids or bile salts. It's going to emulsify fat globules into smaller fat droplets to increase the surface area for lipid digestion. So it's not quite an enzyme because it's not a protein, but it is going to help with digestion. So the substrate for bile are the fat globules, which are big masses of lipids, and it's going to break it down. So the product would be the fat droplets or lipid droplets because they're smaller. And this allows the enzymes to then act on the fat droplets. So you've got more surface area. And yes, it's just like the dishwashing commercials where it shows the Dawn, I think, where it says it cuts the grease. That's what bile does. Okay. The liver makes the bile, but it has to go to the gallbladder in order to be processed and made more effective. The gallbladder is going to receive the bile from the liver, and then it's going to get, more concentrated. So it's basically going to suck out the water So if we look at the diagram here, the bile is going to come this way. And the only tube where bile can go in two directions is this cystic duct. So it goes into and comes out of the gallbladder. The gallbladder is going to remove water and make it more potent so that it acts better and more quickly. Then the bile proceeds down that common bile duct into the duodenum. Now, because bile has lipids in it, and because we're removing water, in some people, they develop gallstones. And so they would fill up one or more parts of the gallbladder. And that would impair the flow of bile. And so sometimes the gallbladder has to be removed. Now, the current procedure is using a couple of different small incisions and cutting it into smaller pieces to remove it. The old procedure, they basically had to cut you in half. They opened you up from the anterior surface around to the back to get to the gallbladder. So it's a much better procedure now. If they take the gallbladder out, they're going to try and save as much of the cystic duct as they can. And that's because it can do some of that concentrating of the bile. Some people don't notice a difference when they've had their gallbladder removed, and others notice they can't handle certain foods. And it's just going to be on an individual basis as to what foods that they can and can't handle. I have one friend who doesn't digest lettuce like she used to, and I would think that there's not a whole lot of lipids in lettuce, but she can't eat lettuce since she had her gallbladder out. Other people can't have high lipid foods, so it's irritating to their digestive tract. So that's the gallbladder. Now, another thing you need to realize is that this picture here, they have everything all spread out. Inside you, it's all smashed together. And so when you have problems and it looks like your symptoms are coming from the pancreas, they need to look not only at the pancreas, but the gallbladder and the liver, because it's all smashed in there. If it's a liver symptom, they still need to look at the gallbladder and the pancreas, because again, it's all smashed in there together. The pancreas is an organ made out of both endocrine and exocrine tissue. The endocrine tissue is part of the endocrine system and not part of the digestive system. The exocrine tissue is part of the digestive system, and that tissue secretes pancreatic juice to drain into that hepatopancreatic ampulla, which goes into the small intestine. It also has this accessory duct, which mostly releases bicarbonate. So pancreatic juice includes enzymes, bicarbonate ions, and zymogens. Enzymes are going to be active when they get created. Zymogens are inactive. So it's kind of like having an envelope that has the dried glue on part of it so that you can wet that glue and make it active. So the inactive or zymogen would be the dried glue. The rest of the pancreas, like I said, is made out of endocrine tissue, but that's not our purview in this system. We already covered the endocrine portion of the pancreas in the first semester. So, digestive function of the pancreas is the secretion of the pancreatic juice. And same thing with the components, the specific components. We'll take a look at those with the digestive assignment. So then we go back to the gastrointestinal tract. The small intestine has the same simple columnar epithelium for the mucosa. It's going to have these finger-like projections that we see here, and that's to increase surface area. You have a lumen, and so with these villi, it increases the surface area without taking up a whole lot of extra space. You also have circular folds. That's these indentations. You can see several of them. And don't forget that at the center of each villus is the lacteal, which absorbs lipids. So the villi, the circular folds, and the length help to increase the surface area. So functions for the small intestine would be absorption of lipids, chemical digestion, and absorption of nutrients. Peristalsis, as usual. Now, the small intestine does something different than the rest of the digestive tract. The small intestine anchors its enzymes to the mucosa. So rather than like in the mouth where saliva is dumped into the middle and you have to have the mastication to mix it all up, with the small intestine, it's anchored to, oops, the mucosa. So the enzymes kind of stick out here from the villi. And so as the liquid goes over the surface, then you have digestion because the lumen's smaller and it's a liquid that's passing through. It can effectively digest molecules as they pass by. In addition to chemical digestion, you're going to see absorption, which we've already mentioned, and then again, peristalsis. So in the small intestine, you're going to see peristalsis of chyme and eventually some feces. So it's a mixture. Some of the digestive processes are completed and some of them are not, because we still have the large intestine. Okay, the large intestine or colon has the least modifications to that 4 basic layers of tissue. It does have some smaller indentations called haustrum. So this is a haustrum. You can see it's got an indentation. It's not a completely sectioned off, but you have these little pockets to create sections. The colon is going to have intestinal flora, which we acquire from the foods that we eat. And we need that for bacterial digestion to break down certain things. And we need it to secrete, we need the bacteria to secrete certain parts of the B vitamins and K. K, going back to being a needed quantity, needed chemical to make certain clotting factors. So most of the water absorption here occurs here. We also see the compression of the material, and so it collects them, and then you have mass movements 3 or 4 times a day. So the compression is going to take place within the haustra to try and make it into smaller pieces, or try and solidify them. And then you have big movements where you have more material moved at a time. And so that corresponds with bowel movements. Some people have bowel movements every day. Some people have them every other day, every 2 days. It just depends. With the mass movements, sometimes you get the bowel movement, and sometimes it's just moving it through part of the colon. Okay, now we mentioned the barium swallow with the esophagus. In the colon, there's a couple of things they can do to test. There's a barium enema where they insert the barium and then take x-rays to see if there's protrusions or indentations, etc. They can go in with a scope and look at the sigmoid colon. That would be a sigmoidoscopy. And that's because it changes directions twice in a short span of time, a short span of space. A colonoscopy is when they go and run the camera all the way through the colon. And so that's why the colon has to be empty so that they can see the tissue and not feces. Okay, so composition of feces. This is what's left over. We couldn't digest it or we couldn't absorb it. No, it's not sterile because it's loaded with bacteria. So this is leftovers. 75% water, even though we pulled out as much water as we can. 25% solids. Of that 25% solids, 30% is the bacterial flora. So yes, we excrete the bacteria and we acquire it from the foods that we eat. 30% is undigested fiber or cellulose. That's the material that we need to clean out the digestive tract. We don't get nutrients from it, but we do get the mechanism of cleaning out debris. 10 to 20% are lipids from the breakdown of cells and bacteria, not from the lipids we consume. We typically absorb all the lipids we consume. And then you have small amounts of sloughed off cells because as material moves through a tube, it's going to knock off cells. You have mucus and you have salts. Okay. In addition to feces, we also generate flatus or gas, about 500 milliliters per day. Most of it's swallowed air, so nitrogen, carbon dioxide, and hydrogen gas. The smelly components are methane, hydrogen sulfide, indole, and skatole. Yes, some individuals are more prolific at making really, really smelly gas or flatus. Goober number 3, oh my gosh. He is not allowed to pass gas in the house or especially in the car. He has to go outside because he's nasty with his smell. And his son inherited the same trait. And so he's going to have to stop passing gas inside too. Okay, so, and just so you know, a lot of times you don't know when you're passing gas. It doesn't always come out in large quantities. It does leak out in small amounts throughout the day. Okay, defecation, like micturition, defecation, you're going to have baroreceptors or stretch receptors in the wall of the rectum. Oops. As it fills up, it's going to trigger what we call enteric and spinal reflexes. So again, the reflex center is in the spinal cord. The rectum is going to relax as it fills up, and then it's going to contract to empty and push the feces out. There is an internal sphincter of smooth muscle tissue that's going to work in opposition to the wall of the rectum. So as it's relaxed, this is going to be contracted to keep the feces from passing out. It's going to relax when the wall of the rectum contracts. The external sphincter is right next to the internal sphincter. Again, you have skeletal muscle tissue that's going to contract and relax as long as you have muscle tone. You do have to relax that in order to relax and pass the feces out. Just like with urine, you have the Valsalva reflex that can increase the pressure in the abdominal cavity to push the feces out more forcefully. So, again, acquiring muscle tone and control and realizing or recognizing the contraction of the rectum and relaxation of the internal sphincter is again something that's a neurological milestone to achieve bowel control. Again, like the micturition reflex, that can be lost in a stroke. So that's the end of chapter 25 on the digestive system.